tell you what is a function of several variables. So suppose we take a Euclidean space of dimension m over r, where m is now bigger than 1, because here we are strictly not talking about our functions of a single variable. So suppose that D is a subset of Rm, and we basically are going to consider functions that are from D to R. So real valued functions on a subset of Rm, the Euclidean space of dimension m. So for the most purpose of this course, we will restrict our attention to the case when m is equal to 2. So here you may think of the situation like you have a machine, so which takes uh, two outputs at a time and produces a real number. So x is a real number, y is a real number, and f of xy is a real number. So this machine takes two inputs, two real valued inputs at one point of time, and gives me a real output. So this is basically what we are going to consider in the remaining part of the course. There are some definitions that I wanted to tell you about during this short video. So suppose that D is a subset of R2, and suppose that f is a function from D to R. So we say that the graph of f is the following set. It consists of points where the points in R3 which are of the form x, y, f of x, y, and where x and y come from D. So you have seen graphs of functions in single variables. So suppose we want to plot a function or an equation y equal to fx. What you would do is that you will pick up a point from the x-axis and you will figure out what is the corresponding value of y. So y equal to f of x, say, and you are going to plot this point in a two-dimensional Euclidean space. But now, since we have inputs from two-dimensional Euclidean space and then output in R, so we are going to have a three-dimensional Euclidean space where the graph has to be plotted. So similarly, what you will do is that you will take, so suppose that this is x-axis, y-axis, z-axis. So you will choose a point xy. If this is in the domain of the function, then you will look for the corresponding output. So you will look at what is f of xy, and you will choose the point in the corresponding three-dimensional Euclidean space whose coordinates are x, y, f of x, y, and you will plot this, and you are going to do that for all the points in the domain of the function. So this is the notion of graph of a function. So a new thing is what is a contour line. So here suppose we fix a real number c in R. We are going to say that the contour line corresponding to c of the function is given by this set. So x, y, c, where f of x, y is equal to c. So you look at the graph and you look for all the points on the graph whose z coordinate is equal to c. So in particular, if you want to look at it geometrically, so this is just the intersection of graph of f with the plane which is given by the equation z equal to c. And what is a level curve? So level curve is as follows. So for example, if I want to look at a single variable situation, and suppose that we want to check for how many values, for what are the values of y, or what are the values of x such that f of x is equal to y. So in this case, what we are going to do is that we are going to fix a real number c, and we ask for what are the points in the domain such that f of xy is equal to c. So in particular, what you are going to do is that you are going to take the contour line corresponding to this point c in R, and you are going to project it to the xy plane. So all those things are explained in this example. So suppose we are going to look at the upper hemisphere of a sphere whose radius is equal to 3. So what is the equation of such a sphere? It is going to be given by x square plus y square plus z square is equal to 9. So this is how we are going to construct in the graph of the function. So we should understand what is the corresponding d and what is the corresponding f, so that we can come to this picture. So let us go through it one by one. First, d is a region which is given by set of all points x y such that x square plus y square is less than or equal to 9. So this is our xy plane, this is our x axis, y axis, z axis. So for the time being, if you forget the z axis, so if you only consider the xy plane, so what is this region d there? Here we are going to get a circle which intersects the x-axis at the point 30, y-axis at the point 03, and you can thus draw the circle, and you are going to take all the points inside this circle. And now what do? You take this function f from d to r. So it is given by f of xy to be square root of 9 minus x square minus y square, and here we are going to take only positive square root, because if we allowed both the square roots, then it is not going to be a function anymore. Okay, so you can see that the graph of the function is the upper hemisphere. So it somehow looks like this. I do not know how nicely it is understood in this picture, but it somehow looks like this. And so what are contour lines? So suppose I have chosen this value c equal to 2. So here what I am going to do is that I will look for all the points on the graph whose z coordinate is 2. So in particular what we are going to do is that we are going to draw a plane whose equation is given by z equal to 2, and we will see that this plane cuts the sphere on a circle, and the circle is going to be our contour line. So this is the set of all points x, y, 2 such that xy in D and x square plus y square plus 2 square is equal to 9. So this is what we are going to get. And what is the corresponding level curve? So as I have said, you are just going to project this to x-axis, xy plane, and whatever picture you are going to get is the corresponding level curve. So here we are looking for functions. So we are looking for elements of the domain xy in D such that x square plus y square plus 2 square is equal to 9. So we are looking for points xy in D such that x square plus y square is equal to 5. So just to make sure that you do not mess up these two things, so note that even though these things look almost the same, the final equation x square plus y square equal to 5 here also, but this is strictly speaking a point inside R3, or you can think of it as a point on the plane which is given by the equation z equal to c. On the other hand, this point, the points on the level curves lie on our domain. So this is in particular a subset of R2, which is our xy plane here. So it can so happen that if you had chosen c equal to 0, then you would say that okay, I have chosen c equal to 0, so then I'm back to this case xy plane. But still there will be a difference, because here we are going to take only a 2 tuple, and here we are going to take a 3 tuple. So there, if you want to take z equal to 0, all the points would look like x comma y comma 0 such that xy belongs to D, z bigger than or equal to 0, and x square plus y square is equal to 9. So this is all about this is a small introduction to what are the functions of several variables and a few terminologies. So we will talk about limit, continuity, partial derivatives differentiability of multivariable functions in the span of our next couple of videos.